So just a little reminder. Okay. Good morning again, everyone. It is 9:40 in the morning Central Time, but it is 7:40 where Katy Wolf is going to be presenting to us from. So she is on the West Coast. She can let us know. I'm not sure if you're in Seattle today or California, Katy, but I'll let you kind of introduce yourself. You're looking at her screen right now, so we really appreciate Katy being here today to share her expertise and experience with us. She is a wealth of knowledge and experience. So she's a consultant with PPRC, which is the Pollution Prevention Regional Center. I'll let you explain that, Katy, and define that acronym for us. So with that, I will turn it over to you, Katy.
Thank you, Nancy. And yes, it is early here. I'm going to talk, good morning, everyone, and I'm going to talk today about alternatives in vapor degreasing. And as we all know, vapor degreasing is a process that's used by numerous aerospace companies in the country for cleaning their parts. And Katy McNamara described the TSCA amendment, so I won't go into that in detail because you obviously now know everything about it. But suffice it to say that EPA developed a list of priority chemicals, and there were 10 of them to begin with, and they have to develop regulations on those applications that they deem to pose an unreasonable risk. Now, as Nancy mentioned, I've been working in the Seattle area for the last several years with the Pacific Northwest Pollution Prevention Resource Center, PPRC. And we wrote a proposal to EPA Region 10 to conduct a project that would focus on safer alternatives to the TSCA listed priority chemicals. And we received funding, and we've been working on that project for a while now. Now, TCE, perchloroethylene, methylene chloride, and N-propyl bromide, all 4 of these chemicals are on the TSCA list of 10 priority chemicals. And they're all widely used in vapor degreasing. And as most of you know, like TCE, these other chemicals are also carcinogens. And EPA has concluded the risk assessments on the 3 other solvents as well that are used in vapor degreasing. And they have also decided that in those cases, vapor degreasing does pose an unreasonable risk. So they'll be regulating all 4 of those chemicals. Now, just to describe the project I've been working on, I've been working in the Seattle area with 3 aerospace subcontractors, and I'm assisting them in converting to safer alternatives. Now, at one time or another, these facilities all probably use trichloroethylene, but all 3 of them at the moment are using N-propyl bromide. And one company I'm working with does non-destructive testing, and I'm going to describe that in more detail. A second company makes small diameter tubing for transferring gases and liquids from one place to another in aircraft. And a third company makes ducting of all kinds for both aerospace and industrial applications. Now, Nancy asked me to talk about my background a little bit, and I will, but I want to do that by presenting the historical context of vapor degreasing. So I'm going to go back in time. After World War II, trichloroethylene started to be used quite widely in vapor degreasing. And somewhat later, perchloroethylene and methylene chloride were also used. Then by the time we hit the 1990s, ozone depleting solvents were very extensively used. And these included 1,1,1 trichloroethane and a chlorofluorocarbon called CFC-113. And as some of you who may be as old as I am can remember, in 1996, the United States joined the Montreal Protocol and banned ozone depleting substance production worldwide. And at that stage, there were 2 million military specifications that were written around 1,1,1 trichloroethane and CFC-113, and all of those in the subsequent years had to be changed. And they have been changed, and largely to be performance-based by now. Now, When the ozone depleting substances were phased out in the late 90s and early 2000s, vendors saw that they could get that market that had been occupied by those two solvents. And so they started introducing new vapor degreasing solvents onto the market. One type of solvent was called the hydrochlorofluorocarbons, the HCFCs, and they also contributed to ozone depletion, but less so than the CFCs. They were, however, phased out in later years for that reason. Then N-propyl bromide came on the market at that time too. Also a number of global warming solvents and another chlorinated solvent called 1,2-trans-dichloroethylene. And over the years, there's been a lot of switching from one solvent to another as one solvent is perceived to be more heavily regulated. So people have just switched from one thing to another for a long time. Now, I spent most of my career in the Los Angeles area, and while there, I ran a nonprofit organization for about 30 years. And the aim of the nonprofit organization was to find safer alternatives for virtually all different types of solvent applications, including vapor degreasing. And I worked with a number of aerospace companies to assist them in converting to alternatives when the ozone depleting substances were banned. This was in the early 2000s. For example, I worked with a company with Rocketdyne, which was located in Canoga Park there. And Rocketdyne, it turns out, had 21 vapor degreasers that used 1,1,1-trichloroethane. And all of those vapor degreasers had to be converted to alternatives. Now, as many of you may know, they have a very strong regulatory regime in Southern California, where the South Coast Air Quality Management District is located. And that agency actually passed a lot of air regulations, primarily motivated because of the smog problem. And the regulations affected both VOCs and toxics. And they had regulations in place by maybe the early 2000s that prevented the use of most solvents in open top vapor degreasers. So what I did in my work was I largely converted companies, assisted them in converting to water-based cleaners and other safe alternatives. And I felt like instead of switching from one thing to another, that would provide a permanent solution. And at that time, water cleaner suppliers and water cleaning equipment suppliers started really selling their products. And their products evolved in the years thereafter, and they become very standardized today. And at this point, as I already mentioned, I'm working as a consultant in Seattle with PPRC. Now, I just wanted to go over the whole range of different potential alternatives to trichloroethylene to begin with. Of course, you can use, one option is to use the other halogenated solvents, N-propyl bromide perchloroethylene or methylene chloride. But as I also mentioned, these are covered under the first 10, the list of the first 10 priority chemicals under TSCA, so regulations are likely to be developed for them. They're also heavily regulated under a number of other regulatory statutes, so they're probably not a good option. A second option would be to use fluorinated solvents. The hydrofluoroethers, hydrofluorocarbons, and hydrofluoroolefins. The HFEs and HFCs contribute to global warming, and they may be regulated in the future for that reason. The HFEs and HFCs also do not clean well, so they're almost always combined with a chlorinated solvent, 1,2-trans-dichloroethylene that I already mentioned, to boost their cleaning capability. Now, 1,2-trans-dichloroethylene has not been tested for chronic toxicity, but it is structurally similar to TCE, PERC, and vinyl chloride, and those are all carcinogens. So it's likely it's a carcinogen as well. The HFEs and the HFCs are also extremely expensive, so they're almost always not used in open-top vapor degreasers. Rather, they're used in enclosed equipment, things like vacuum degreasers. Now, in order to buy a vacuum degreaser of the smallest type that would be available, you might have to pay around 100 grand. So there's a very stiff price if you want to use those chemicals. Now, the HFO that's used in vapor degreasing does not contribute to global warming. A toxicologist in California, however, has evaluated its toxicity and has decided that it is cardiotoxic. It's not used in enclosed systems. It's used in open top systems that are designed specifically for use with it. And they are expensive as well. Now, a third option is to use solvents with flash points in vapor degreasing. Now, you can't really use solvents with flash points in an open top vapor degreaser. If you did, you'd hit the flash point before you hit the boiling point. And if there were a source of ignition, you could ignite the vapor degreaser or blow it up. And nobody wants to do that, obviously. So you have to use solvents with flash points in enclosed systems. Again, very expensive systems. The types of solvents that have flash points that I'm talking about here include 1,2-trans-dichloroethylene, which I already mentioned, oxygenated solvents like modified alcohols or glycol ethers, and various hydrocarbons. Then a fourth option would be to use these solvents with flash points in a cold cleaning operation. Cold cleaning, however, is not as effective an operation as is vapor degreasing, so this would be inapplicable for most types of operations. Now, I've separated out soy-based cleaners here, and they're appropriate in certain instances. For example, if you're making optical components, you need to polish those components, and you use materials like pitch and wax. Pitch is sort of like asphalt, and it's very difficult to remove, and soy-based cleaners are especially effective in doing that. Now, water-based cleaners are, of course, another option, and I'm going to talk much more about them in what I have to say in the next several slides. Then there are various other methods that can be used in certain instances. For example, you might use a burn-off oven to decompose certain types of oil. If you're assembling printed circuit boards, you might convert to a no-clean flux, which then subsequently doesn't need to be cleaned off. If you're bringing in heavily contaminated parts from the field, you might use blasting media of various kinds to clean them. Now, taking into account all the health and environmental effects of everything that I've discussed, the costs for using certain processes and the technical feasibility, the most appropriate alternatives for use for nearly all operations that today use vapor degreasers are water-based cleaners. And as I also mentioned, soy-based cleaners or various other methods are also appropriate in certain cases. Now, it turns out in the PPRC project I'm working on, all of the facilities are converting to water-based cleaners. I am working on another project with a California agency, however, and one of the facilities I'm working with makes optical components, and they are converting to a soy-based cleaner. Now, I want to present a case study example, a company called MAPSCO in the Seattle area. I think it's very important to have case studies because other people can relate to what the company went through to convert and how they did the conversion. So MAPSCO is an aerospace subcontractor that does non-destructive testing. And the type of non-destructive testing they do is magnetic particle inspection. Now, I'm sure all of you are familiar with non-destructive testing because you're from aerospace, but in case there are people who are not, I'll just describe briefly how they do their testing. There's a non-destructive testing fluid, and it contains magnetic particles. And you put the part into the fluid and you magnetize it. The magnetic particles will tend to congregate in a place on the part if there's a crack or a flaw. So you can identify where it is and you can repair the part rather than disposing of it altogether. And for many years, MAPSCO used a large 130-gallon N-propyl bromide vapor degreaser. Now, we tested a water-based cleaner. They wanted to use a particular one that they were using in other parts of their operation. It's made by a company called Brulin, and it's called 815GD. And we tested that cleaner, and it was effective in removing their soils. We tested in the Brulin lab, where they have different kinds of equipment. We tested in 2 different kinds of equipment. One was a simple immersion agitation, and the other was ultrasonics. We were able to clean the parts effectively in immersion agitation, which was good because ultrasonics are more expensive. So I brought in an equipment supplier that had immersion agitation systems of the type that MAPSCO needed. And the quote on the equipment was higher than MAPSCO wanted to pay. And the equipment supplier also represented another company that had cheaper equipment, but the quote on that was too high for MAPSCO as well. So then MAPSCO was able to find a second-hand system, but another company bought it before they could get it. Then I got in gear and identified a company that had second-hand systems of just the type we had originally quoted. MAPSCO was able to purchase it, they installed it, and they've been operating it for maybe 6 months, and the system's working very well. So here's a picture of the non-destructive testing stand at MAPSCO. This picture shows the 130-gallon vapor degreaser that they used to use. And here's a picture of the water cleaning system that they purchased. It's made by Ramco. It has 2 wash baths, 2 rinse baths, and a forced air dry. It also has an automated handling system that indexes the baskets into the appropriate chamber for cleaning. Now, when I work with companies, I like to do a cost analysis and comparison of the before and after, the vapor degreaser in this case, and the water cleaning system. I think it's very useful for the company itself, but also for other people to see the information. And I generally present the cost in the form of an annualized cost, because I think that's inherently sort of, it's intuitively understandable. Now, I generally don't show a capital cost for the vapor degreaser because most vapor degreasers, as you know, are very old and they've been fully amortized and paid off. But I do include the capital costs of the water cleaning system. And in this case, the water cleaning system cost $55,000. MAPSCO also upgraded their electrical system to convert to the water cleaning system. And since that was a one-time cost, I also included it in the capital cost. Now I amortized that cost over a 10-year life for the system. And the system will probably last at least 20 years or even longer, but to be conservative, I used a 10-year life. Then as you see here, the cost of the cleaner in the case of the vapor degreaser for the N-propyl bromide is much higher than the cost for the water-based cleaner. That follows from the fact that water-based cleaners are generally sold in concentrate form, and they run about $20 a gallon. And you're gonna, when you use that, you're also going to dilute it to 5 or 10% concentration. And if you have very good oil control and filtration in your bath, you won't need to change it out very often. So the cost of using the water cleaner is actually quite low. Now I do show a row for water here. And when I worked in Los Angeles, the quality of the water was very poor, and almost all companies had to use deionized water for rinsing so they could get a spot-free part. In contrast, in the Seattle area, the water quality is a lot better. So MAPSCO was able to get away with using tap water for their rinse, so I don't show a cost for that. This system does have oil removal and filtration, so I show a cost for the filters there. Now, as you see, the energy cost for using the vapor degreaser is higher than the energy cost for using the water cleaning system. This is because you have to heat the N-propyl bromide to its boiling point of about 160 degrees. And it turns out that the vapor degreaser they had 2 sets of cooling coils, and it's expensive to condense that solvent and hold it in the tank. The vapor degreaser also had an internal distillation system, and that contributed to the energy cost as well. Now, as you see, the labor cost for using the water cleaner increased slightly. This is because the company is cleaning a few more parts, some parts that go through a masked operation in this cleaning system as well. Now, I don't show a cost for the personal protective equipment for the vapor degreaser. If you saw the picture of the vapor degreaser, it's enclosed and the workers did not need to use PPE. Now, as you see, the disposal cost for the vapor degreaser is quite high. Even though the vapor degreaser had an internal distillation system, you still have to dispose of the still bottom. Halogenated solvents are really expensive to dispose of because they have to be incinerated. So that's why that cost is very high. MAPSCO has a very large wastewater treatment system in another part of their facility. And they were able to change out the wash bath when they needed to periodically and the rinse bath and put them into the wastewater treatment facility that they have. And it was only a slightly increased incremental load to the high volume of water they were already processing. So we decided to ignore that cost. Now, as you see, the total cost of using the vapor degreaser is higher than the cost of using the water cleaning system. MAPSCO was able to reduce their costs by about 27% by converting to the water-based cleaner. A second company, as I mentioned, makes small diameter tubing. And we did conduct testing in the Brulin lab, and we found a cleaner that could be both sprayed and used in immersion systems that worked well in this case for their soils. And I did some additional testing with an equipment supplier. We knew of another company in the Southern California area who had a similar operation, who had converted several years before, and they had converted to an ultrasonic system. But knowing that ultrasonic systems were expensive, we wanted to try to clean the parts in a spray cabinet with a specialized fixture. So we did all that testing, and we were able to show that we could clean the parts in a spray cabinet. Now, we've given the company 2 quotes for a spray cabinet and an ultrasonic immersion system, and they're evaluating them right now. Now, the other company that I have been working with manufactures ducts, as I mentioned, and they have a number of other water cleaning operations in their facility, and they wanted to convert to one water-based cleaner company-wide. And so we decided on a cleaner after we did some testing that can be used in both spray and immersion. They have systems of various kinds, and it was able to clean their parts effectively. Now, that cleaner did not have approval with their OEM. So Brulin actually is conducting all the testing to get approval for that cleaner. And the OEM has given the company I'm working with approval to use that cleaner. They are going to be able to use an existing immersion agitation water-based cleaning system. In principle, we would like to use ultrasonics on these parts. That would be the most effective cleaning operation, but the company cannot get approval from their OEM for that. The OEM is afraid that the parts will be damaged with ultrasonics. So we're still doing testing to make sure we can clean all the parts in immersion agitation. Now, I know that you face issues when you try to convert, and I know that I encounter lots of issues when I work with companies who are going to convert. And I just thought I'd talk about a few of those. Companies in the beginning nearly always want to drop in an alternative, and you have to know a great deal about the alternatives to know that that just isn't going to happen. As I described what all the alternatives were, I think you saw some of the limitations. And some vendors who are kind of irresponsible will try to sell you systems as well that may not be appropriate for your operation. You don't want to use 1,2-trans dichloroethylene, for example, in an open top vapor degreaser and blow it up. But vendors, in a few of them, will sell you things like that. Others are very good, of course. Then a second issue is that companies are often skeptical that water-based cleaners will be able to clean their parts. There are a number of water cleaning suppliers and water equipment suppliers, however, who are very good, and they can do demonstrations of cleaning your parts, and all of that is free. And as I mentioned, even some water cleaner suppliers will do all the testing for getting approval for a cleaner if that's the one you need to use. So getting some tests done ahead of time can show and demonstrate that water-based cleaners will work. Now, you also need to try and make the alternative cleaning system as low cost as possible. Nobody wants to pay a lot of money to put in a new system. So I always try to do that. The secondhand system is an example. You also have to be prepared to be able to estimate operating costs. People don't always know what their operating costs are. For example, you don't individually meter the energy cost that goes to a vapor degreaser. So you may have to get a very old vapor degreaser manual and look through it to try to estimate the horsepower and the kW that you'll need to calculate the energy costs. Or you may need to call the vapor degreaser manufacturer. You need to be able to just know how to estimate those costs if people don't know what they are. Now, as all of you know, COVID-19 has affected businesses in various ways. Some companies' business has declined substantially and they simply don't have the money to purchase an alternative system. Other companies I've found are doing very well, so there's been a disparate effect. Then I want to mention one last thing. When I worked all those years in the Los Angeles area, the companies I worked with are just much more aware that there's a regulatory regime. They always knew there were regulations that were in existence or that were coming down the pike. And so they were fairly open to converting and getting ahead of the game. In contrast, in other parts of the country, like where I am now, there's less incentive to convert. So you have to find other reasons to help companies decide to convert. Just to conclude then, water-based cleaning systems are the best alternative, in my view, for the vast majority of vapor degreasing operations that are done today. And in nearly all cases, you can make it work. Other safer alternatives can be used in some situations where they would offer an advantage. Now, you really need to have a lot of expertise on what the implications of using the alternatives are to be able to understand that there's no drop-in or magic answer. It isn't going to come. You have to actually do the work to convert, and it's definitely worth it in the end. You don't have to switch back and forth from one thing to another anymore. So here's my contact information. I'm giving my phone number and my email, and please feel free to call or email me and describe your process, and I'll be glad to talk to you about what alternatives might be available for you. So that concludes my presentation, and I think I'll be glad to answer questions. Is that right, Nancy?
Yes, let's take a few minutes to do that. Katy, thank you so much for sharing your knowledge there and experience. Those are really good, really good information and the history too. I think that's really important to understand. So do we have questions? If we do, feel free to unmute yourself, ask the question. You can put your camera on. You can chat your question or raise your hand. Okay.
And Nancy, we do have one question in the chat. Someone asked, could you share the information on the testing from California finding the cardiotoxicity? We would be extremely interested in reading about that and sharing with TURI.
Yes, I will try to find it.
Great. All righty, and that was from Alicia, and she also can contact you directly if she's got some other specific interests. And so I do have one question, Katy, and I'll try to describe it. So I believe it was MAPCO, the first company that you talked about that went from the vapor degreaser to the water-based cleaner. And they had their own water treatment facility right at their plant. And many of our facilities do have that. I'm wondering if the resultant effluent from changing out the water-based cleaner increased any metals or any contaminants for that wastewater treatment system that we'd need to be worried about, you know, essentially, causing another regulatory issue from the effluent of that cleaner.
Right. They're processing a lot of wastewater through their wastewater treatment system, and they have good control already for filtration and neutralization, that sort of thing. And these cleaners, most water-based cleaners that are used in cleaning parts are somewhat either slightly alkaline to very alkaline. And so neutralization will take care of that. And the incremental increase in the loading is very low. Like if you have a wash bath that's 60 gallons and you change that out once a month, you're just putting 60 gallons a month of that water through a wastewater treatment system. And as you probably know, most wastewater treatment systems are generally there because they treat many larger quantities of water than that. So it's only a small incremental increase, and generally it will be okay. I mean, in the end, if you ended up using a water-based cleaner that had a pH of 13 and you dilute it to 10%, that'll give it a pH of 12. But you could still neutralize that in a wastewater treatment system. Now, if you don't have a wastewater treatment system, you dispose of that as water waste through a disposal company. And depending on what you're loading in there, of course, it may or may not be hazardous waste. Most water-based cleaning operations that I've worked on historically, they have had, they are not usually RCRA hazardous waste. They may be hazardous waste for other reasons. Like in California, the fish toxicity test always makes everything be hazardous waste practically. But that and the rinse water, of course, is even less contaminated. So however often you have to dispose of that, it would not contribute to much of an increase either.
Okay, great. Thank you. I'm specifically thinking about, chromium in the case of cleaning metals. And so that often is what we see. Sometimes you can capture that with just the filter then, and then the filter has to be tested for like a TCLP for chromium before you can, you understand how you need to dispose of it. So I just wanted to ask that question. I appreciate that. Terry is asking, what was the largest system that you looked at in terms of feet long?
In terms of what?
In terms of feet. So if you're looking at a bath or a vapor degreaser, what was the largest system, either gallons or he's asking in terms of feet?
I worked with one aerospace company in California who had a 2,000 gallon vapor degreaser. And the tube manufacturer that I'm working with right now, those are, I don't know, 6 feet, 5 feet long. But the 2,000 gallon one was probably the biggest one I worked with.
All right. Great. Hopefully we answered your question. Don't be shy if you want to unmute yourself and ask more of a specific question. You're welcome to do that. Again, we will have a little bit of a discussion time at the end. and Katy and others. If you're able to stay on for that, that's great. If you aren't, we understand. We have your contact information. Okay, I'm not seeing any.
Let me just mention, I really would encourage people to give me a call or to email me. I'm more than happy to discuss operations with people if they don't want to ask a question now.
Excellent.
And
Yeah, this is Hanson from Boeing. I can ask a question that if we still have time.
Please.
So there are some system that's closed loop system. I know it's not perfect that get rid of TCE completely, but the system is already there, and consider the challenge of finding alternative timely, especially for some of critical use application. Is that intermediate kind of solution, because that really addresses the work exposure concern, right? It's not perfect, but probably cut 90% of work exposure. So do you think that's maybe not so perfect solution, but maybe the right thing to do at this time?
It's a good point, and I'll just say a couple things about that. First, it's worth noting that EPA in their risk assessment found that enclosed systems, like you're talking about, still pose an unreasonable risk. So if they decide to go forward with a phase out or something like that for all 4 of the vapor degreasing solvents, you would have difficulty doing that. And I want to emphasize again, you can buy vacuum degreasers, airless, airtight degreasers. And in fact, the South Coast Air Quality Management District regulation allows the continued use of many of these solvents, including TCE, in airless, airtight systems. But as I also mentioned, vacuum systems are extremely expensive. You need to pull a vacuum on the whole system. So if you need a big one, you're going to pay $1 million for that. So you have to take into account that it's going to be unbelievably expensive. And I do agree that if you're going to buy a vacuum system for your parts, that TCE would be the right one to use. TCE is the best vapor degreasing solvent there is, depending, of course, on the types of soils that you're removing. There might be others that would be better. But definitely you can do that. It's just that it's an unbelievably high cost. And I don't generally encounter people who have a ton of money to spend, $1 million to spend on a system. Does that answer the question?
Yeah, yes. So that's why, I'm glad the EPA is part of the meeting as well. That's why I'm saying, when we look at the alternatives, we consider the balance, right? The exposure, the impact to human health and the environment, as well as the economic cost. If the closed system, and it's just talking actually in general, if the alternative addresses the majority of the concern, and then the cost is much less, will that be a good enough solution instead of just 100%, ban, and then the cost will be very, very, very expensive. They make company bankrupt or whatever. I'm using that as example. I'm trying to kind of see the gauge, what are the general sense people, because company probably have to take those things into consideration, right? Finding alternative, it's not that easy. How much ahead of time we should start working on it, so make sure we will be meeting the regulation deadline, right? You don't want to be like, say, oh, it's gonna be banned, and then you don't have a solution, then end up disrupting your business. So I think you answered some of my question, and I think I have a one question on this and a bigger question in general, how those, and TC is a perfect example of illustrating, the environmental impact as well as the potential cost impact on some specific applications. Yeah, I like your presentation very much. The case study is so real, so much we can relate to. So really appreciate your effort.
Oh, thank you very much. I do want to emphasize, however, that there are some really good suppliers out there who can work with you. At least you should test some alternatives to see if you could use them. You know, it's always worth it to do that. And they do it all for free. You know, because
yeah, that's exactly what we are doing right now.
Oh, good.
Yeah,
good.
yeah, definitely. Yeah.
But consider water-based cleaners. I mean, people just assume water-based cleaners can't be used because they'll corrode the parts or whatever. But the water-based cleaners that exist today are extremely good.
Yeah, we'll agree with you.
Okay.
Thank you.
Great. Thank you. Thank you for that question.
There was one other question in the chat, which actually leads into what you were just saying. Somebody said, no doubt that an aqueous-based system is the ultimate solution. One major concern is how effective on cleaning the oil-based contaminants. And could you share your experience with that?
Sure. I mean, water-based cleaners aren't just water. They have surfactants in them as well that are very effective and surfactants have two ends. One that is soluble in water and one that's soluble in oil. So they're very good at removing oil-based material of all kinds. And that's not all water-based cleaners. I mean, there are some really bad ones out there too, of course, so you have to be careful. And a lot of the water cleaners have solvent additives in them, and I tend to stay away from those. You really don't need them. If a water-based cleaner is formulated properly, it can be very effective in cleaning oils.
That is great. I think we got all the questions. Thank you, Allison, for pointing that one out. There were a few I had missed, but I think we've covered them all now. Looking through them. Is that correct, Allison?
Yes.
Great. All right. Thank you, everyone, for your questions and discussion. Katy, thank you so much for your time and dedication, your work on this project and sharing what you're doing with PPRC. We really appreciate it. And like Katy said, you know, don't hesitate to reach out to her. She is a wealth of knowledge. So it's been great to get to work with her this fall. So thank you, Katy.
Thanks, Nancy. And I'm staying around for the rest. So if people have questions at the end, I'll be glad to talk with them.
Great. And I'll just have you stop sharing at the top of your screen. You'll be able to hit the stop share button.
Yes, I will do that.
Okay, super. And with that, we're going to roll right into our next speaker. And it just dovetails perfectly, especially with discussion on doing testing. Because there are some opportunities that the Toxic Use Reduction Institute is offering to our audience. And with that, I'm going to let Alicia take it away.
Thank you so much. And Katy, that was a wonderful presentation. So my name is Alicia McCarthy, and I'm the laboratory specialist at the Toxic Use Reduction Institute. And I also have my colleague, Hayley Hudson, who is our EHS and our specialist in the lab, and she's been doing a lot on our alternatives assessments. So I'm going to have her talk near the end, kind of what we're doing related to halogenated solvents. There we go. So just for those who don't know who TURI is, we're actually part of a law that was created in 1989 called the Toxic Use Reduction Act here in Massachusetts. And it was created to be able to promote competitive advantages for Massachusetts businesses while reducing their toxic use of chemicals. So it's a really unique program because it's funded through, you know, these basically companies have to pay fees for utilizing certain higher hazard chemicals, and those fees actually go back into the program, and it provides them with services of laboratory testing, which could cost a lot of money for some people, or for those in Massachusetts that may not even know about those other programs, especially the smaller companies. We also provide training, and what those companies have to do is they actually have to create a plan, sort of like what Katie was talking about, of just even reviewing what options you have in testing in-house or working with someone, of just saying, okay, this is our process. How does it work? What do we utilize? What are we using right now to clean? And what are our options that are out there currently? And it allows them to kind of put that all down on paper and look at the economics of it, and also the feasibility of implementation and getting input from their clients. So it's not enforceable, but it gets them to start thinking about that. So that way they can then get out of the program if they're paying fees for it. And how the structure actually works for TURI is we have the Massachusetts Department of Environmental Protection, which they're the enforcing group. They actually look over the planner certification and data analysis. We have an Office of Technical Assistance, which do more confidential technical assistance for free and on-site review to ensure that they're meeting the standards that Mass DEP is setting, and also looking at the equipment side of things. And then there's TURI, which is where Hayley and I work. And we're more of a research-based organization. So we do training, we give out grants to small and large businesses here in Massachusetts. So say if they can't afford the equipment that they need to switch to be able to get to a safer alternative, we'll actually have them apply to like a 1-2 page application where they could get up to $30,000 to buy new equipment. We provide alternatives assessments, policy analysis, and we also have a laboratory and library that is free for organizations and also industries to utilize. So the laboratory itself was created in 1994, and we work in such sectors as industry, janitorial testing for third-party certification, households, so helping certain maybe nonprofit organizations find safer cleaners. And we actually now have a disinfection lab that we have up and running, and we're currently doing COVID-19 testing for safer alternatives to bleach and quats. And what's interesting about our lab is we actually utilize students. We hire on students of all different majors and grades to actually do the testing so they can learn. And once they go out into industry, which we try and promote those types of manufacturing jobs, they get to see that kind of world and go into those different types of businesses. They're more familiar with those processes and they know how to go about looking for safer alternatives. So how does this relate to you? How we can help out-of-state companies is we do performance testing, which is what we would do for Massachusetts companies. And we're not in it for the actual payment. It's more of just paying for the students' time and the resources that we may use. Or it could be through external grants. We just worked with Minnesota Technical Assistance, MNTAP, and they had a P2 grant, which they then contracted us to be able to help 4 different companies in Minnesota that were using TCE to remove 300,000 pounds of TCE from their process. So what we would do is do a site visit if possible. During COVID, it's a little bit harder, so we've been doing virtual site visits. We do an EHS assessment of the different alternatives that are out there. For cases where there may not be alternatives straight for you to be able to pick from on the market, we've actually been kind of playing around with what's known as Hanson solubility testing. It basically looks at the solubility of different types of solvents, and you can make mixtures that have the same solubility as what you're trying to replace. And that's more, it's been used in other applications for more formulation, but we've been playing around with it for cleaning applications for those harder cases. And then we do flexible performance testing. So we may have someone send parts to us and then we'll actually test on them after we've done some preliminary testing on flat surface substrates. And then we also review available products and TURI laboratory testing data. So I'm going to show you a live demo of the Cleaner Solutions database, which is free and available to you. And also an EHS assessment of potential alternatives. We do have a free hazard assessment tool called the Pollution Prevention Options Analysis System that you can utilize. And I'll do a demo of that as well. So to kind of showcase the impact that you can do over time, having these types of resources, whether it be using Katy's resources or other P2 opportunities to be able to reduce TCE, you can see there is definitely a reduction in use and byproducts release over time. The program does work, and it is feasible to switch away from halogenated solvents. So as I mentioned, our main 5 steps for success that we found and what we teach the students too is, you look at the actual process because it's very unique and individual to each person, but it can be applied across the board by just looking at the current process, looking at what you're trying to remove as your contaminant, looking at the substrates to ensure that they work with that process, and kind of playing around with those different variables such as temperature, agitation, time, concentration, and then testing it in the lab on a small scale, but then actually testing on the parts, and then finally piloting, because it's one thing to test in the lab, but it's another thing to actually test in-house to ensure that it works for your process. And what we found too is in certain cases where, say, we may not have the equipment to verify the cleanliness because it could be a private process that you don't feel comfortable sharing, or it's equipment that is specifically towards your process that would not leave your facility, what we would do is actually send back those parts to verify, because at the end of the day, you know what you need best, and you need to meet your client's needs as well. So for someone, whether it be an organization or even your company that's trying to address how to switch from TCE, I always suggest go and do a walkthrough and see every place that you're actually cleaning and what you're using and how much you're using. Because surprisingly, you can find that you might have multiple cleaning processes, and sometimes ones that you've done that you've actually, it's just always been that way, and no one has done anything, and it could be using extra resources that you never intended, but no one thought to change it. Or it could be that, you have another cleaning process that you just were never aware about that you could reduce by switching to something else. And then you can utilize, our database to look at different options that are out there, the Cleaner Solutions database, and then reviewing your options, really kind of figuring out, okay, am I switching to something that is safer than what I'm currently using? And that's what the hazard assessment tool is that I'll show you that we use. And what's interesting about it is it incorporates process in and of itself, because it's one thing to look at the hazards of the actual chemistry that you're utilizing, but how it's being used as well. And we kind of talked about that with the closed systems with that previous question. And then performance testing is huge. And then finally, piloting. So as I mentioned, we just worked with Minnesota Technical Assistance Program, and I wanted to share this resource for you as well. We had done a bunch of webinars and training for them before we actually started the testing for those companies, and also did site visits. So these are free and up for you to go through and see our process and look at different case studies that they have on hand. And feel free to reach out to them. They're a great resource just to hear about their story and going through it, because they went through a grant system and they were, like I said, they were able to reduce a decent amount of TCE from different applications. And we actually are on contract with them right now to help out individual companies as well. So we're still assisting them. And I wanted to show you quickly what our test request form looks like. And this is available to you online. And if you ever want to just get our feedback just on different options, it doesn't even have to be testing, but if you just wanted to fill it out and just say, hey, what options maybe do I want to look at? What's out there? Feel free to fill it out. And I gave you the link down below for our online version. But even if you utilize it as your own tool to be able to go through during a site visit walkthrough and just kind of see, okay, what are we using? What do we need to think about when we're doing internal testing? Or this information could be used to give to Katy or someone else who may be assisting you. So I'm going to actually exit out of this and do a demo instead. So we're going to first talk about the Cleaner Solutions database. So this is our database. It's the cleanersolutions.org, and feel free to open up while you're watching as well. This is a hub for all the testing that we've done thus far at TURI in the lab over the years since 1994. And it's always changing. This is actually an upgraded version, and we're still trying to get feedback on what are the needs of the users to ensure that this is a workable database for them to constantly learn from and add from. And what's nice is you can look at, for example, find a product. So you can actually click on there, and you can click multiple different options. I'll actually just pick one. We'll do, for example, someone had talked about oil. So we could do oil and say if it was on aluminum. And sometimes you can do equipment, but I always find it's just helpful just to see what options are out there. So we could just do return effective results only, and then you hit submit. And this actually will showcase what we've tested in-house or things that we have in the database that we know about for different types of cleaners. We have a safety evaluation that's based off of P2ACES, as I mentioned, which we'll go over, but it looks at the acute human effects, chronic human effects, ecological hazards, environmental fate and transport, atmospheric hazards, physical properties, and then the process factors that we talked about, and potential life cycle factors. And what's key to note is the safety evaluations for process are set standardized as if you were working in a lab. So when you go into P2ACES, you definitely need to go in and edit it to fit your needs, but it could be a starting point for you. We have it by classifications, so you can actually figure out by classification if you're looking for aqueous specifically, and it'll tell you what types of contaminants it worked on, what type of substrates it worked on, and the method that was utilized, and you can actually look at the reports too. So that's one way of doing it. You can also look at replacing a solvent option, which same thing, we could pick and do TCE. There we go. And it could just be that if I wanted to do effective only. And it will show you all the different cases where we were helping a company possibly, or it could have just been in-house testing that we were doing on different types of cleaners. So this is a really good starting point for some of you that were like, where do I even go from here? You could at least go in here and check out to see what other people have been testing that we tested for them. And we do have the case studies in there too. We try and do it as the final report if we finish for a company to kind of let you know, the whole process, what they switched to, and if we have an equipment information, we have it in there as well. And you can go into browse client types, so we have it by different industries as well. Here in Massachusetts, we really don't have a lot of aerospace. We did have we had three, but these were from Minnesota and a couple of other applications. So feel free to go through and actually look at them to see if it works for your application as well. And then we also have vendor and product search. So you can actually check out different types of classifications and just see what's out on the market right now. We try and keep it relatively updated. We go in, every month or so and kind of check through just to make sure that these products are still on the market, if anything has changed. We do not have pricing because that always fluctuates, but it still gives you a starting point of where to look. And as I mentioned, the client test request form, you can actually go under our forms and it's on here as well if you want to go about that route. So yeah, that's kind of the main thing of our Cleaner Solutions database. It's supposed to be for you, the user, or for anyone else who is assisting someone to be able to find options and get a starting point. The second thing that I wanted to go over was our pollution prevention options analysis system, P2ACES. So when you go to the site, it won't look like this off the top. It will say sample here. But say if you're curious about a certain type of chemical and you want to see if it's even in our database, which means that myself or our director of the lab has inputted it and looked through, we'll actually go through and you can type in, you can search the database. There we go. Say if you're wanting to start off, we already have it in there, but you can click and add to the session and you can pick different ones in there. And then that's when you would edit it. but you can actually look and enter in those data. And the data actually comes from safety data sheets, and we also give resources for trusted databases. We are interested in potentially doing toxicity testing to kind of fill some of those data gaps with collaborations with people from UMass Lowell. But that's still in the process. But for right now, this gives you a relatively good idea of, am I going in the right direction when you start filling this stuff out? And that way you can kind of compare it side by side of going, okay, well, I was starting with a pretty high hazard where 10 is the highest and 2 is the lowest. You can see here the scores, or less preferred would be 10. And you can see here, N-propyl bromides actually has higher acute issues compared to TCE, but then you can look at the other options and go, okay, hey, I'm heading in the right direction, or, oh, this metal NOx M6386, it really lacks some data gaps in some areas that I'm concerned about that may make me question it, or I want to do more research on that area if that's something that I want to switch to. So this is more of a discussion tool. It allows you to really fill out the hazards that you may be concerned about, your process factors, thinking about, the ergonomic hazards. If you're going from, using a lot of energy to using less energy, it's definitely where you need to bring in multiple people and experts within your facility, but it allows you to be able to upload it and kind of have that discussion together and say, hey, would you agree that this is an ergonomic hazard if we're doing this? You can have the EHS person talk about it. You can have the engineer talking about more of the equipment side of things. So feel free to use this as a way to kind of lay out your options of what you're thinking of switching to. And we do have tutorials under the help section that will go into more detail on how to actually use the tool itself. They're all videos, but feel free if at any point in time, if you want to reach out to us and kind of get a training of how to utilize this tool or even cleaner solutions, we'd be more than happy to help. And I had mentioned the Hanson solubility parameters in practice. I'm not going to go into this too much, but for those who were curious about what I was talking about of looking at different solubility applications, this is the actual tool that we use. It's a one-time purchase. I believe it's $1,000. However, it's a very powerful tool with a lot of chemistries that you can do basic testing of just figuring out if you can look at different safer solvent or mixtures to work for your application. We've used it for replacing certain higher hazard solvents in adhesives, for example. And then we had some students that did a great job. They most of them were chemists or chemical engineers. They created this resource called DOS, not the old computer system, but it's dos.turi.org. And this actually works in conjunction with the HSPIP, where they went through and worked with a bunch of different vendors to add in safer potential solvents to look at, where you could actually select, export, and use that file to upload into this program. Because there's a lot of nasty solvents that are listed in Hanson solubility and you can't look by EHS. So we wanted to give an option for people to look at saying, oh, we only use nitrile gloves at my facility. What types of solvents will work with that? Or I'm looking for a specific hazard rating. So we're still playing around with that. We would love feedback to see how this works, if you would be able to use it. And, if you're going to end up using the tool itself, please let us know. We're always interested. So that kind of sums up for the most part. This is the website for MinTap with all of the recordings that I mentioned. And then let me just pull this back up for you guys. So yeah, and then I wanted to give Hayley just a couple of minutes just to quickly talk about our alternatives assessment for halogenated solvents. So Hayley, if you wanted to go ahead.
Great. We've just got about four minutes or so, if that's possible.
Perfect.
Great. Thank you.
Thank you, Nancy, and thank you, Alicia. So I just wanted to, real quick, I don't want to take too much time for this, but we originally had thought we were going to do an alternatives assessment for halogenated solvents. And I'm sure, as all of you know, that's a pretty wide range of options. And there's just so many variables to consider. So we have actually moved it to be a guide. to replacing halogenated solvents. So I just actually want to give an opportunity for anybody that would like to provide feedback, or that would be so helpful to us. This has been a long process trying to create this guide, and we've used a lot of the tools that Alicia went through today and a lot of the points that Katy made today. So it would be just great for us if anybody wanted to provide any feedback, or if you would like to reach out, I would be happy to send it to you, and that would just be so helpful for us. Thank you.
Great. And that ends my presentation. Feel free to reach out to Hayley or myself if you have any questions, or if you want more information on the tools, training guides, or even just review of certain types of chemistries. We'd be more than happy to help with that.
That's great. Thank you, Alicia and Hayley, very, very much. They have offered to, possibly work with someone on taking their parts and doing some testing. So if you, definitely consider taking them up on that either now or in the future, and we can always connect you to them. Are there questions? We can take a couple minutes of questions. I know that Krister Hellstrand is here from the International Aerospace Environmental Group, and he is going to provide a brief update. He does have a meeting in a few minutes, but I do want to see if there's any immediate questions for TURI. Okay, I'm not seeing any. Are you, Allison?
No.
Okay. And so we'll just transition. Thank you so much again, Alicia and Hayley, for your presentation. You are welcome to stay on. We will be having kind of a discussion later, and as everyone knows, but just a reminder, these presentations are being recorded. They will be on our YouTube site and then linked to our K-State Pollution Prevention Institute site. So we will let folks know when those are posted, as well as any contact information people may need. So with that, Krister, if you are on still and available, you can unmute yourself and provide us with a short update, please.
Okay, can you guys hear me all right?
Yes, we can. Thank you.
So, so one of the members here, Shan Ying, she can really provide more details should you want some more information. But I will just give a very, very brief overview of IAEG and what we have accomplished now recently. And so we have several work groups, and I will just highlight some key accomplishments by each of the work groups. So we have one on materials and substance declaration, and they have updated their aerospace and defense declarable substance list. It's now version 4. Further, they have a Excel-based tool that can be used, which is really aimed at companies that don't have large IT system that support this process. Is called the Aerospace and Defense Substance Reporting Tool, and that has been updated recently. We also have a work group where we have several project teams that are working on replacement technologies, and a couple of accomplishments so far recently. We completed a project on actual corrosion inhibiting epoxy primers, and the result of this was a screening specification detailing a set of product requirements that are available to support an initial evaluation of potential EU REACH compliant coating. We also had completed the first phase of our bond primer project, and we're going into a second phase now. We finished a project on hard chrome plating, and we also supported SAE, and when they developed their AMS standard, AMS 2461, for zinc nickel plating as an alternative to actual cadmium plating on standard parts such as electrical connectors and fasteners. And we also have a project on non-chromate chemical conversion coating. And they have done a lot of round-robin testing, and they have tested the first 3 possible solutions. They are into the next 3, and they are looking at corrosion and electrical contact resistance. Another project that we have, another work group we have, is working on greenhouse gas management and reporting. And they have finalized and developed a guide for Scope 3 reporting regarding purchased goods and services, as well as the actual capital goods. And they have further developed a tool for this type of reporting that is now in beta test, and hopefully it will be released next year. We have one work group that is working on EU REACH authorization, and they have completed the mapping of the EU REACH Annex 14 editions, which is banned substances. They completed the mapping to understand the impact on the aerospace industry and whether or not we need to form consortium to do REACH applications. We have a work group that is working on ISO 14000 environmental management system implementation, and last year they finalized a framework for maturity, a framework for maturity matrix, and which is really an implementation guide for small and medium-sized companies that do not have the resources nor the risk profile that warrants a full-blown ISO 14001 implementation. And in addition to the requirement documentation, we now have a implementation guide where we have resources and examples. And we also have translations of these documents into several different languages. And finally, we have another work group that is working on emerging regulations. So they scan emerging regulations in 30 countries, and they have issued so far this year approximately 10 regulatory alerts, and that is an explanation of the regulation and the potential impact to our industry. And just a couple of examples that they've done. They have one on UK REACH, which is really essential to our industry, of course. One on the EU Waste Framework Directive. There's a South Korean REACH update, and the China Minister of Ecology and Environment. They issued something called Order 12, which has a tremendous amount of information and new requirements in it. And that's just really, really quick. So if you have any question, if you let Shaniying know, and she can answer, or if you have some questions, you can always get back to me.
Krister, thank you for taking the time. That is quite an update. And just if you could tell people who are your typical members. I know there are several of your members are on this training today, but just can you describe your typical membership? And I know you're international.
So we have Airbus, Boeing, we have Bombardier, Embraer, Rolls-Royce, GE Aviation, Pratt & Whitney, Raytheon Technologies, we have Thales, we have Safran, and that's just to mention a few. So we really have basically all OEMs, or most of the global OEMs, plus most of the tier ones. But we are very, very interested to get what I call tier 2 or tier 3, or even further in the supply chain, because it is very important to understand the impact on the whole supply chain on the tools that we develop, and we want them to really work for everybody. So if anybody has any interest in membership or just want to have a chat with me, please reach out, and I'll be more than happy to discuss further.
Excellent. Thank you so much. And there in your agenda, their website is hyperlinked. It's a very user-friendly website. And I do really appreciate, do you have any meetings planned? I know you typically do 2 meetings a year.
Well, so unfortunately, with the COVID situation, our meetings have gone from face-to-face meetings to virtual meetings, and I doubt that we'll have any meetings this year, 2021. But hopefully, we can revert back to face-to-face meetings in the spring of 2022.
Okay, great. Krister, thank you so much. Any questions for Krister before he leaves? He does have to jump off. All right. Thank you so much.
Okay.
I really appreciate your time today.
Thank you. Bye now.
Thank you. Bye-bye.
Bye.
All right. And we had invited David Hyde. He did not think he could make it, and I don't think David is on from the Aerospace Industry Association. Unless Allison or David, you seeing?
I'm not seeing him.
Okay, great. So David just briefly provided me with an update saying they don't have much going on right now because of COVID. Their group is located, and let me just ask, Allison, am I sharing my slides?
Yes.
Okay, great. Just want to make sure I've got the right screen up here. David is the environmental policy contact with the Aerospace Industry Association, AIA, and they are located in Washington, D.C. They are what EPA has a certain program called EPA Smart Sectors, and they are considered one of the aerospace smart sector partners. Smart sectors is just kind of being developed right now, or either that or it's on hold. I haven't seen a lot of action come out of smart sectors in the last 6 months, but the association is part of that, and as we learn more, we think it's good for this group here to learn more about it. We will certainly provide those resources. All right. Oh, I'm going to stop sharing for a second here. And so next on our agenda, we wanted to talk a little bit about a partnership that we're doing with Spirit, and Alex Tobia and and so Alex, you're on and you're unmuted. If you want to show your camera, that's great. If you don't, that's okay too.
Yes, I'm here, and I unfortunately do not have a camera, so.
All right, well, I'm going to kill mine then, if that's okay. All right, so Alex and I are working together on a project, and we just wanted to take a couple minutes to share it because this was an opportunity that that we had, and we went for it, and we've just been funded to implement it. And so, Alex, I changed these slides just slightly from the last time we presented these in October. So not very much at all, but if you want to speak to this one, that would be great.
Yeah, so Nancy and I have had a pretty good working relationship, gosh, for quite a while now. We've been working together on the air quality task force when the ozone standard was rearing its ugly head and risking Wichita to be out of compliance with that standard. So we had worked on that together. We also see each other at the Kansas Environmental Conference and attend meetings there together. Of course, we've always attended the TCE roundtables because of our vapor degreasing that we do at Spirit. And the information that we get from these has been extremely useful. And of course, Spirit also provides letter of support for various projects that the Pollution Prevention Institute does. And so basically it was, gosh, late in 2019 that Nancy had approached us and asked us, hey, do you want to do a hazardous waste reduction project with us through an EPA grant? And we said, yes, that would sound fantastic. And so we decided on our solvent usage, not necessarily degreasing solvent. It's more along the lines of solvent wipes, that sort of thing. And as anyone who does aluminum aircraft manufacturing can attest to, there is an awful lot of solvent wiping done on those aircraft. So that's where we are today.
Yeah, and so it was actually just, I think, last February, about a year ago, that we reached out. We actually reached out to Mike Price, Textron as well, and so both Spirit and Textron have been great partners and champions, providing us with letters of support for various pollution prevention projects that we proposed to EPA. We had a food and beverage manufacturer, a large one, as well. And the grant we're writing for we felt it was best if the grant we wrote for, it was a little smaller, just served one sector. So we did hear from both Aerospace and Spirit, came back, and Alex and I just started talking about, if we were going to do this, what would we want to look at? Then as a result, we put this proposal together, and they helped us review. They helped us kind of put together as well as review and approve what we put in our proposal for goals. And basically what this project is going to do is fund us to work with them specifically on this solvent reduction project, that our goal is to reduce overall solvent use by 10% for each manufactured airplane. And we will be using a summer pollution prevention intern in the summers of 2021. We're pretty sure that's going to go forward despite COVID restrictions, and hopefully with some vaccines, as well as we will have an intern in 2022. And both Allison and I will be working on this. We're going to have, we put together some estimated outcomes, which I just mentioned. And then both the trade associations that we just mentioned a few minutes ago, both of them were very interested in this, provided letters of support for us, and have asked us, once the project is over, if we could present at one of their conferences. And so that would probably be in 2022, late 2022, early 2023. So Alex, do you want to speak to kind of the projects that we set up?
Right. So
or the goals rather, sorry.
Yeah. The goals here is, so we're going to basically establish a solvent use advisory board within Spirit. So we're going to essentially find the subject matter experts and the people essentially responsible for the majority of the solvent usage at our facility. And then once we've established that, we're going to inform them of what we'll be doing and basically get their buy-in so that we can have internal facility support while we're going about doing this. We're not just going to start and have people come to us saying, hey, what are you doing? So that's definitely the step number one. Step number two is to investigate and study the high solvent usage areas and practices. We have a pretty good idea right now, but I think ultimately what we're going to do is is essentially a dumpster dive, which we've done in the past, where we take our larger hazardous waste containers, empty them out, and see what's in them. That way we can effectively figure out where exactly our high use solvent areas are. And then we'll figure out what that solvent is being used for in those areas, and then we'll evaluate how we can reduce those usages for it. That will probably involve, actually investigating what some of those workers are using and actually watch them do their jobs essentially. So once we finish that, well, then we'll publish the training videos and a case study for internal usage at Spirit, and then basically through that we'll increase awareness of solvent usage through our internal trainings and through the trade association partner events, because that's definitely an important part of this. Is Spirit's not just going to keep this to ourselves, we're going to be giving this to basically anybody who wants it.
Awesome. Yeah, and so that's what we call, and EPA calls, project transferability. And that is why all these programs around the country are working to put together case studies and make sure that we're publishing them. And we have over 80 case studies on our pollution prevention intern case study website. These are 2-page documents that have a specific format to them, that also then have a table which indicate what the recommendation was, what the environmental outcome is either estimated to be, or if it was implemented, is the cost, because cost is very important. Obviously, we have to make the business case for making changes to material, technology, or processes, and then the status of whether it's been implemented or not. And so that's what these case studies are all about. The training videos, like Alex just said, they will all these procedures and things will be hopefully be able to be used by other companies to implement and have similar success. So the use of these pollution prevention interns that we have, they literally spend are on site full time. In most cases, we do have some short-term interns available as well, but in most cases, they are on site full time. They are the ones following or working with the technicians, seeing them from the time they get the solvent from the crib, how much is dispensed, then how is it used, what happens at the end of the day, how much is used, documenting, putting all these spreadsheets together so that we can identify opportunities for changing the process, probably mainly in this situation, but certainly in other situations, it's technology or possibly material change solutions. So that's what our interns do. I'm just putting a little plug in. I told Alex I was going to do this. Little plug for our intern program, because we are accepting applications from Kansas Industries right now, and we would love to work with you. So please message Allison or I if you want any more information about that. We're happy to provide that information to you, but now is the time to apply for those programs, or at least express some interest so that we can get you in the queue if it's appropriate. So with that, Alex, is there anything else you want to say about this project?
Nope, just look forward to getting it started.
All right, absolutely. We do too. So we're very excited about this, and we're really appreciative of our aerospace partners. In this case, Spirit is going to be great to work with. Are there any questions about this project? One of the reasons that we want to share this with you, that I want to share this with you, is because if you've got some projects that you want to do or some ideas on projects, and you're looking for a partner who may be able to apply for grant funding, we have been very, very fortunate at the Pollution Prevention Institute to be successful with our competitive grant proposals. And that's because we've had good industry partners, we've had letters of support, and we've had some pretty good implementation rates in the past with regard to our projects being implemented. And so I know about next year at this time, we will actually be putting together another round of very competitive proposals. And so if there's a project that you've had on the list that you would like to do something similar to this, or possibly some testing that may involve some researchers like either Katy or Alicia's group, we would be happy to work with you on that and see if we can't get the funding to help support that, or at least funding in part to help support that. So let us know if that's something of interest. Okay, with that, I just want to take a few minutes here